This is the solution video for section 7.3, problem number 8. So the directions here just say evaluate each definite integral. All right, so I have the definite integral from 1 to 4 of the square root of 16 x to the 5th. All right, now there's two ways that you could do this, right? So you realize that you have the square root of 16 x to the 5th. And so some people think, okay, well, I take whatever's under the root here, and I say, okay, that's u, right, 16 x to the 5th. But the problem is that du would be equal to 5 times, so 80 x to the 4th dx. Now, that's a problem because you don't have an x to the 4th on the outside. And so that approach wouldn't work. And so what you want to do is you actually need to rewrite this here. So I would say, okay, well, this is the integral from 1 to 4, but now the square root of 16 times this square root of x to the 5th dx. Now, that's nice because the square root of 16 is 4, so I can put a 4 on the outside. And then I have the integral from 1 to 4 of x to the 5 halves dx. Now, this is the one that I can integrate, and I do not need a u substitution. All right, so I have the 4 on the outside. All right, so now integral of x to the 5 halves. So remember, we're going to add 1 to the power, so x to the 7 halves divided by 7 halves, and then remember we evaluate from 1 to 4. All right, so now simplify a little bit. 7 halves, dividing by 7 halves is like multiplying by 2 sevenths, and so 4 times 2 sevenths is 8 sevenths times x to the 7 halves from 1 to 4. All right, so now I have 8 sevenths times 4 to the 7 halves minus 8 sevenths times 1 to the 7 halves. All right, so remember, okay, the 7 halves means the square root of to the 7th. And so I always evaluate the root first. So I have 8 sevenths times the square root of 4 is 2. 2 to the 7th is a little bit easier to do. 2 to the 7th is 32 is 5th, 6th, 7th. So that should be 128, I believe. All right, minus 8 sevenths times 1, so 8 sevenths. All right, so 8 times 128, well, that's kind of annoying, but it actually ends up being 2 to the 10th, right? So if I multiply by another 2, that's 256 times another 2, 512 times another 2 is 1,024. So I have 1,024 sevenths minus 8 sevenths. So that's actually pretty reasonable, 1,016 sevenths.